All right, another kind of introductory type video here for this section before we start actual examples that would be similar to the homework. So let's call this one symmetry. We are going to talk about two different types of symmetry in this particular section. One of those types of symmetry will be y-axis symmetry. This is also called even symmetry. And the reason why it's called even will be a little bit more easy to explain in our next section, so I'll save it for then. But even symmetry, that's another word for y-axis symmetry. And let's see here. I think the best way to look at symmetry, especially when you're introduced to it, is to just look at some examples. So I'm going to put some graphs up here that have y-axis symmetry or that have even symmetry. Let's start with something like this. And my graph's not perfect here, but I think you get the idea of what I'm going for. Now, y-axis symmetry, really what it's saying is if you can reflect a function over the y-axis and get the exact same function back after you reflect it, well, then that function is symmetric about the y-axis. And so one way you could test these is, I'll do it in yellow here, I'm going to take the function, the part of the function that's to the left of the origin, and I'm going to reflect that over to the right. And if I do that, it looks something like this. So far, so good. And now I'm going to take the part on the right-hand side of the origin. I'm going to reflect it, just do a mirror image to the left part of the graph over the y-axis. And if I do that, it looks something like this. And so it looks like I get the exact same graph back if I reflect this over the y-axis. If I just do a mirror image about the y-axis there, I get the exact same graph back. Now, on the other hand, so actually let's label that. So this function here is even, or it does have y-axis symmetry, however you'd like to say that. On the other hand, let's look at something that does not have y-axis symmetry. I just gave it away, but that's okay. Maybe something, let's just do a line. Let's just do a basic line. All right, so here's a new function for us to look at. Now, if I reflect this guy about the y-axis, I'll do the upper right-hand side first. So if I reflect that about the y-axis, it's going to look something like this. And then the lower left-hand side, if I reflect that about the y-axis, looks something like that. And that is not the original graph that I started with. It's not the original graph that I started with, so this is not even. And I'll go ahead and push this up a little bit and look at the next type of symmetry here. It's going to be called origin symmetry or odd symmetry. Let's go ahead and write that down. And it looks good right about there. So origin symmetry. Or odd symmetry. That's the other word for it. Again, I'll explain those terms in our next section. They'll mean a little bit more to you then. So let's see here. Let's look at something that has origin symmetry. So I keep giving it away, but it's not a big deal. So something that has origin symmetry, maybe something that looks like this. And so the way to check something like this, we want to make sure it's a mirror image about the origin, so not the y-axis like our last one. We just want to make sure it's a mirror image about the origin. One nice way to do this, though, it takes a little bit longer, but I think the best way to do it, especially when you're starting out, is to first reflect the graph about the y-axis and then reflect the graph about the x-axis. If you do both of those things and you get back to the exact same graph, then that graph is symmetric about the origin. So, and the order doesn't matter. You could do x first and then y. I don't know why I do y first and then x. It doesn't matter which order you do it in. So I'll go ahead and reflect this over the y-axis first. So the part in the upper right in the first quadrant, I'm going to reflect that into the second quadrant. I'm going to dash it in here just because I still need to reflect it over the x-axis, but right now I'm just going to worry about the y-axis. So I'm going to take the part in the lower left there in the third quadrant, reflect that into the lower right, into the fourth quadrant. So here my dashed line, this is the reflection over the y-axis. Now I need to take that y-axis reflection that I just did and reflect it over the x-axis. So I'm going to look at the part that's in the second quadrant. I'm going to reflect that over the x-axis. That's going to move it down to the third quadrant. And then I'll take the part in the fourth quadrant. I'm going to reflect that over the x-axis. That's going to move it up into the first quadrant. And when I did this, I reflected it over the x and the y-axis. I did y first, then x. And I got the exact same graph that I started with. And so yes, this is symmetric about the origin. So this is odd. And let's do another one up here. So let's say something like this. Let's do a graph, maybe one of those ones that we knew was symmetric about the y-axis, maybe just something like this. Let's check this out. Let's see if this has origin symmetry. So the first thing I'm going to do is reflect it about the y-axis. Well, that's not too bad. I'm going to move the part on the right to the left, the part on the left to the right. So I'm done with the y-axis reflection. Now I'm going to reflect it over the x-axis. So everything that's above the x-axis now is going to move below the x-axis. And it was all above, so it was all going to be below now. And unfortunately, my green final graph there is not exactly the same as my original white graph. And because I didn't get the exact same graph when I reflected it over the x-axis and the y-axis, I did y first, then x. And this is not going to be odd. So this is not odd. It does not have origin symmetry.